Hello, I'm Elsa Panciroli, and you're listening to Paleocast. One of my favourite cartoons ever is The Land Before Time. In this 1988 movie, a group of young dinosaurs find themselves alone in the Mesozoic world when a disaster strikes, and they have to find their way to safety and their families. They strive through trials and tribulations on their journey, not least the lead character, a sauropod dinosaur named Littlefoot, who tragically loses his mum and has to continue without her. I'm not crying, you're crying. This epic journey of these baby dinosaurs is stirring and exciting, but it's an animation, so probably not all that realistic, is it? These animals are portrayed as coming from loving, close and extended families, sometimes part of a wider herd. What do we actually know about the lives of baby dinosaurs? The fossils of juvenile and embryonic dinosaurs are rare, but those that have been found are filling in the picture of their lives. Littlefoot and his companions, being reptiles, were of course born from eggs, but did they hatch alone or as part of larger clutches? How quickly did they grow? And were real baby dinosaurs as punishingly cute as their animated counterparts? Well, to answer some of these questions, I'm speaking to Dr Kimi Chappelle, a researcher from South Africa who specialises in the first sauropods. Dr Chappelle was recently voted by the Mail and Guardian as one of the top 200 South Africans in science and technology. She joined me to talk about her work on fossils from South Africa and an incredible study she published with her co-authors recently, which gives us new insights into embryonic sauropodomorphs. So, welcome to Paleocast, Kimi. It's great to have you here, especially from so far away, the opposite side of the world. Could I start by asking you to kind of introduce yourself to our listeners? So, in your own words, like, what do you do? What's your background? What are you interested in?
Sure. I'm currently a postdoctoral fellow at the Evolutionary Studies Institute in Johannesburg, South Africa. The Evolutionary Studies Institute is at the University of the Witwatersrand in Joburg. I got my Bachelor of Science, my honors, my master's, and my PhD at Wits University. So I've been there for a while. But this year is my first year of postdoc there. And I'm actually supposed to be moving to New York in a couple of months to take up a
Oh,
postdoc at the AMNH there. So that's exciting. Um, and I mainly work, or actually, my research has basically focused on Massespondulus carinatus, which is a very iconic South African dinosaur. And more recently, I've mainly focused on its ontogeny, so its development and how it grew. And yeah.
cool. Oh, wow. Well, congratulations. That sounds really exciting, New York. Wow.
Yeah, I'm super chuffed. Should be fun.
So I noticed, well, first off, I guess I should say you're going to have to forgive me because I don't actually know all that much about dinosaurs. So hopefully you can teach me about them today when we're do our conversation. So I guess that kind of leads to my first question. I noticed on Twitter that it says that you're really into basal sauropodomorphs. So I know what a sauropod is. So what's a basal sauropodomorph?
Okay, as you say, a lot of people know the derived sauropods, so the big guys like Diplodocus and Brachiosaurus. Um, the big quadrupedal sort of multi-ton animals. But originally, or I mean, those guys evolved from much smaller animals, basal sauropodomorph dinosaurs, which are typically bipedal, also plant-eating dinosaurs. But for example, Massespondulus only weighs about half a ton, so they are just much smaller and quite different looking animals.
So did all dinosaurs come from these bipedal ancestors?
As in all sauropods, or like all dinosaurs in general?
Both, I guess.
Well, yeah, so I mean that's the locomotion in dinosaurs shifts a lot. So it is currently the hypothesis is that the ancestors to dinosaurs would have been a small bipedal animal, and then quadrupedality evolved several times in different lineages.
Oh. Oh, so what is it about basal sauropodomorphs that makes them really important?
Well, I mean, I don't know. I've always found it's very interesting to look at where things come from, right? So like sauropod dinosaurs are very unique because they're so big, and then the physiology that goes along with being so big. Um, and so I find it quite interesting to try and figure out how they attained those body sizes or those sort of that architecture that they have. And in order to do that, you have to go back and look at ancestors, and in this case, basal sauropodomorph dinosaurs. So the firsts and the very early animals and lineages I find are very interesting to look at.
So when you say they were small, how small are we talking? Like the size of, I don't know, a dog or smaller?
No, no, bigger than that. So Massespondulus is about probably 5 meters long from tip to tail to tip to snout. They do have a long neck and a very small head. Um, so they're still quite long, but they're nowhere near sort of the multi-ton uh, derived sauropods that we all know about.
So so you talk a lot about Massespondulus. So tell me a little bit more about that. What is it? Like you've told me it's a basal sauropodomorph, but like where does it come from and where does it sit? Why is this one that you seem to have quite a connection with this particular species and genus? What is it about it that you love?
Yeah, I mean, it's Massespondylus is sort of my baby because I've been working on it for so long, so I'm slightly biased. But it's it's an amazing taxon to work on. So it's Southern African, so we find it in the Upper Elliot and Clarence formations of South Africa, Lesotho, and Zimbabwe. So it's a very proudly South African dinosaur, and it's very abundant. So we have hundreds of specimens referred to it in South African collections alone. So that's not even including specimens in London and in Zimbabwe and so on and so forth. And the very neat thing about the Massespondylus fossil record is that the specimens range in size from embryos all the way to adults. So you can track the development and growth of the taxon um, quite easily, or not easily, but quite well, I would say, which is quite rare in dinosaur fossil record or in any fossil record to have such an abundant size series that you can look at.
Hmm, that's quite amazing. It's cool because a lot of the time we do hear so much about North American dinosaurs and of course Chinese dinosaurs now with such amazing ones being found. It's really cool that there's like a really iconic South African dinosaur as well because you're quite into promoting South African paleontology, aren't you?
Yeah, I mean, I think so. It's interesting because in the academic world or in the sort of professional world, obviously a lot of paleontologists know how important the fossil record is in South Africa, and a lot of people travel to South Africa to look at the fossils. But if you talk to the general public, they usually have no idea in South Africa that we have all of these fossils, including dinosaurs or mammal ancestors and so on and so forth. They usually know more about the hominids, but not so much about all the other sort of amazing fossil vertebrates that we have. So I think it's quite important to showcase the South African fossil record.
So what time period are we talking about for Massespondylus?
So it's early Jurassic, so about 200 million years ago.
Okay, wow. Yeah, that's right. So right at the beginning, this is really quite early on. And at what point do these sauropodomorphs start becoming like proper sauropods, as it were? When does that happen?
Yeah, I mean that's a good question because I mean the true sauropods um, obviously evolve much later, but you have all of these transitional phases in between. So things like, for example, Volcanodon is a very early sauropod that's from Zimbabwe. Um, and so I think actually it's sort of not a night and day scenario where you go from basal sauropodomorph to sauropod. There are transitional phases in between there.
Hmm. So is it into the early Jurassic, that sort of time period that we start to get the sauropods?
True sauropods?
Yeah.
Yeah, so I mean, they do start appearing sort of late early Jurassic, I would say.
Okay. Hmm. Well, cool. Well, I mean, you're talking there about the amazing range of different Massespondylus fossils that you have, and actually, that you recently published a quite an exceptional paper on that in Scientific Reports. That was on dinosaur embryos, wasn't it? Can you tell me a bit more about that paper and what you found, what it was about?
Sure. So the Massespondulus embryos are preserved in a clutch of 7 eggs that came from Golden Gate Highlands National Park, which is in the Free State of South Africa. It was discovered in 1976 by James Kitching, who's sort of a very famous South African fossil hunter. And they were first published on in 1979 as being sort of very preliminary papers saying that these are dinosaur eggs, but not going in depth as to what they are. And then it's only later with Robert Rice and colleagues' work that these embryos were described. So there's several papers that came out in the early 2000s, and they were referred to Massespondulus, and their anatomy was described. And then the interesting thing as well about the nest is that it appears to be a nesting site in Golden Gate. So there's several layers of eggs, and so it would appear that the Massespondulus females would come back to the same site to lay their eggs. But the descriptions of the embryos had been sort of restrained to what was exposed on the surface. So the prep work is exceptional, because these embryos are very, very, very small. They're, probably about 7 centimeters long. So they're tiny little guys. So prepping that must have been quite difficult, I imagine. And so, as part of my PhD in 2015, we took the eggs to the European synchrotron radiation facility in Grenoble to get them micro CT scan or synchrotron scan, because we tried to micro CT scan them using sort of a standard lab scanner, but they're so small that you can't actually pick up on them. So we had to take them to the synchrotron and get them scanned.
And the results are really incredible. I mean, for our listeners, I'll just describe these fossils as depicted in your paper. So the scale bar indicates their size. So they're like, 1.5 centimeters long, some of these little skulls. And like most babies, they have really short, sort of blunt snouts, and the bones of the skull are beautifully digitally segmented. I'm assuming that was by yourself, Kimi.
Yes.
And they look, yeah, I do a lot of that myself, so I know what kind of detailed work that is. You've done an amazing job. And you can see in the different views that the bones don't look like they're fused into a solid skull. They kind of are floating free. So I imagine there must have been a lot of cartilage in the skull because it's so young. Is that right?
Yeah, exactly. So quite a few of the bones haven't even started to ossify yet. As we know, or maybe if people don't know, bones ossify either from cartilage or straight from intermembranous cells. So either those ossification centers hadn't appeared yet, or the cartilage was still present and they hadn't started ossifying yet.
So do you know how young they are? I mean, are they babies or embryos, or what sort of, do you know anything like that?
So based on their size, so the original papers looked at sort of the size of the embryos compared to the size of the egg, and it was assumed that they were very close to hatching.
Oh.
But again, this was based on just the surface preservation, and the synchrotron scans revealed how unossified these little guys actually are. And if we look at the ossification sequences or patterns in modern animals, especially things which are related to dinosaurs, so for example, chickens and crocs and lizards and turtles are all sort of part of this group called Sauria. And if we look at the order in which those embryos ossify, there's usually a very set pattern in which the skulls ossify. And to put it very vaguely, it basically ossifies from the front of the skull to the back of the skull.
Oh.
So the bones of the snout ossify first, and then the bones of the brain case, which are the bones that surround the brain and support the brain, ossify last. And so if we look at the Massespondulus embryos, we can see that the front of the skull is quite well ossified, but what's not ossified is the back of the skull. So the brain case, for example, there's only one bone that we can see in the scans. And so using that and comparing it to modern animals, we can tell that they were probably approximately 60% through their incubation period. So they still had a while to go.
Wow. Do we know how long their incubation period might have been?
We do not. So that is something that I'm hoping to work on in the next few years. So there's been some work done whereby you look at the histology, so the cross sections of the embryonic teeth, and that can help you determine the incubation period.
Mm.
And interestingly, it's been found that dinosaurs actually have much slower incubation periods than previously thought. So they would have an incubation period that's sort of closer to reptiles than it is to birds.
So I guess this is probably a really stupid question, but I'm trying to imagine these nests. So are we talking about, are they coming, they're coming and they're laying their eggs. How many eggs, first of all, are they laying at one time? Do we know that?
Ah, so there's a clutch in. It's from South Africa. It's from Golden Gate, and it was also published in that nesting site paper. And that nest has about 32 eggs in it.
Whoa,
It's at least 32 eggs that we know of.
that's huge.
So yeah, it's quite a lot. Yes, it is. It's quite a lot.
And were they like laying them and then leaving them, or do you think that they protected them in some way? Do we know that?
So there was a hypothesis. So if we look at the nesting site, there's little trackways around the eggs, and it was hypothesized that those were juvenile sort of Massespondulus trackways, and that would mean that even after they hatch, they sort of hang out around the nest. But in a more recent paper, it's the identity of those trackways is sort of put into question. So we don't know actually. So I just whether or not there was parental care, I think we can't really answer that yet.
Because obviously, I mean, thinking about the size of the animal, you were saying incubation, but clearly they're not sitting on these eggs like we would think a bird might do, are they?
Oh, I mean, yeah. So we think that Massespondulus digs basically and makes these big pits in the ground and then sort of buries the eggs. But I mean, there is no reason why they wouldn't. I mean, maybe not sit on them, but sort of brood.
Oh, right. Okay. No, it's just something, I guess this is a picture I hadn't really quite had of dinosaur behavior. It's really amazing when you have a discovery like this that, as well as the sort of biological implications, it's this sort of behavior thing that I think we're seeing here. This is a really rare chance to explore that, isn't it?
Yeah, exactly. I mean, it's to me, it's still amazing that you can find these sort of 200 million-year-old eggs that have embryos in them and try and figure out sort of what female Massespondylus dinosaurs were doing. It's pretty crazy.
I think looking at the pictures of the skulls, one of the things that really strikes me is this huge round space where the eye would have been. And you can just imagine this little creature when it hatched. You imagine, kind of cute, almost cartoonish. I've got this Land Before Time image in my mind of it. I mean, this is not a scientific question, but I bet these little guys are cute.
I have no doubt that they were unbelievably cute and very small.
Well, a much more scientific question. I did read in your paper, in that paper, you said something that I wanted to ask you about. You said that null generation teeth in Massespondulus embryos got reabsorbed or shed before hatching, similar to those of geckos. So I didn't quite understand that. What are null generation teeth?
Yeah, so when we scanned the embryos, one of the surprising things was that we found teeth preserved in the bones of the snout, and or the bones of the jaw rather. And when we reconstructed those teeth, there's two different types of teeth. So one of them is, so to put it into context, sort of adult Massespondylus have these broadly serrated, sort of leaf-shaped teeth. So they're not very small serrations like you would see in meat-eating dinosaurs, where their teeth look more like steak knives. They're these very broad serrations that allows them to break down plant matter. And so in the embryos, we see those teeth. So we see the crowns of teeth with these very large serrations. But then there's another type of tooth which is very, very small and very simple. So it's just a cone, basically. And I got very excited when I found this because I was quite early on in the research, and I thought, maybe they're eating something different, and there's a dietary shift or something cool like that. But it actually turns out that if we look at modern things, so like crocodiles and geckos, for example, when the embryos are still in the eggs, they produce this first generation of teeth, which are usually much more simple than their adult teeth, and they either shed them. So just release them into sort of the egg, or they reabsorb them into the jawbones, which is very interesting. So we think that the Massespondulus teeth that we see would be the equivalent of those null generation teeth.
So obviously my background's in mammals, so when I think about replacing teeth, I think about this kind of single replacement event that you get when a mammal is weaned. But I'm assuming that dinosaurs probably replaced their teeth multiple times as adults. Is that right?
Well, definitely. So if we look at the 2018 paper where we describe the skull of an adult Massespondulus, you can see the replacement teeth coming in, and it looks like I mean, most dinosaurs replace them basically like crocodiles do. So it's just this constant replacement pattern.
Mm. Well, Massespondylus certainly sounds like an amazing animal. Yeah, cool. Well, I love babies, and I think that this is just such a sort of also a visual thing, even for people who aren't into dinosaurs, that just this image of this gigantic sort of early dinosaur creating its nest and having, what did you say, 35, was it, eggs on a nest? That's bonkers, really.
That's a lot. Yeah, it's a lot of eggs.
So, you were recently given an award, weren't you? Or you were recognised by the Mail and Guardian as one of the top 200 young South Africans. So, huge congratulations on that. What an amazing honour.
Thank you very much.
Now, there's over 8,000 nominations for that every year. So, it's quite a prestigious thing to get. How did you feel when you found out that you'd been selected?
Yeah, I mean, so it's actually the interesting sort of thing about that is that you have to get nominated by someone. And so it's already just getting nominated and someone taking the time to nominate you, I thought was quite, I don't know, I was quite pleased about that. And then, yeah, like getting selected out of 8,000 nominations for the science and technology category is, yeah, it's very humbling. It makes you it's a great opportunity to sort of showcase paleontology, as I said earlier on, um, to the South African general public and sort of and try and get them to know more about South African dinosaurs. So no, I was very very chuffed.
Yeah, I can imagine it's very well deserved. I noticed the quote they had from you for that was, "In her ideal world, she'd be able to ask a child what their favorite dinosaur is and have them respond with Massespondulus." So,
That is the dream. One
yeah.
day.
So, as I said earlier, you are a real champion of South African paleontology and South African paleontologists, not just yourself, but others. So, am I right in thinking that you also got to name a new species of South African dinosaur?
I did. So for my PhD, so Massespondylus, another reason which I should have mentioned, I guess, why Massespondylus is quite interesting and neat is that it was one of the first dinosaurs actually named from South Africa. So it was named in 1854 by Sir Richard Owen. And since then, it sort of became this wastebasket taxon, whereby a lot of um, fossils which were found in the same rock layers from which Massespondylus came from were automatically referred to Massespondylus. Um, and the reason for that is I mean, it's quite complicated. But basal sauropodomorph, in order to differentiate between the different taxa, it's quite difficult. The differences are very slight, and there aren't usually sort of there's not one characteristic that makes it like a specific taxon. You have to have this suite of characters. So Massespondylus is a bit different in that it has a very, very long neck vertebra, which is actually what Massespondylus means. And that's quite typical. But if you don't have those neck vertebra, it's very difficult to say that this specimen is definitely Massespondylus. Um, and in fact, the postcranial anatomy of Massespondylus, so the rest of the skeleton, basically excluding the skull, hadn't been described in a lot of detail because it was very similar to Plateosaurus, which is a taxon from Germany. And most of the research focused on the skulls rather than the skeleton. And so it's only in sort of recent years that we've really figured out what makes Massespondylus. And by doing that, you can go back and look at all of these fossils which have been collected over the past, I mean, 200 years basically, to try and determine if they were actually Massespondylus. And the one was 4779, which is a specimen at the Evolutionary Studies Institute. And it was found ages ago. It was found in the 70s as well. And since then had been referred to Massespondulus and had been published on as being Massespondulus and had been included in several papers that looked at sort of the cranial shape change in Massespondulus. But actually, it's an incredible specimen because it includes most of a skeleton which had never been published on. And so part of my PhD was to sort of look at that specimen, and we figured out that it's actually something quite different to Massespondulus. And if we try and analyze it and put it in sort of the phylogenetic tree of basal sauropodomorphs, it doesn't even come out as Massespondulus. So it's not just a different species; it's a completely different genus, and it's more closely related to Lufengasaurus from China than it is to Massespondulus carinatus, at least based on what it looks like. So I got to name it, and we named it Ngwevu Intloko, which means gray skull. And the reason for that is that the skull is gray, and so most people who came to the year site to look at it would just refer to it as the gray skull specimen. So it was a very, very neat opportunity to be able to work on that.
Could you say the name again? Because it's a challenging one for some people. What is it?
So it's pronounced Ngwevu Intloko. So Ngwevu is the genus name and Intloko is the species name. And that means grey skull in Xhosa, which is one of the official languages in South Africa.
Oh, wow, that's really beautiful. And what a great reason to name it. I quite like things like that, where it's just, this is what everyone's been calling it kind of anyway. So it sounds like there's been lots and lots and lots of Massespondulus fossils. Is it quite common?
It is an exceptionally abundant taxon.
Okay.
So, as I previously mentioned, we have over 200 specimens in South African collections alone.
Okay.
So not even that's not even looking at Zimbabwe or London and so on and so forth. So no, we have a lot of them. Look, not all of them are complete skeletons, obviously, as we know when you work with fossils. But we do have a lot of skulls, which is quite rare in dinosaur fossils.
So you mentioned there that Ngwevu was more closely related to, did you say Lufengia in China? Is that right?
Lufengasaurus, yeah, from Yunnan province in China, which is very interesting, actually, I find. But if you look at that group of what we call Massespondulidea dinosaurs, so it includes Lufengasaurus from China and Massespondulus and a few other taxa from here, and some for example, Cerosaurus from North America and Leosaurus from Argentina. So it's a clade that really includes specimens from all around the world and taxa from all around the world. And if you look at how those are related, they're not, the one from South Africa can be more closely related to the one from China, for example, which is quite cool because it really reminds you about how different the world must have looked back then.
That's what I was just thinking. I was wondering, like, biogeographically, how did that work?
Yeah, so 200 million years ago, you don't have sort of the obviously the separation of countries that we have now. So it's there's no reason why you wouldn't have a South African taxon which is more closely related to a Chinese taxon. But it's also indicates that Massespondulidea, or that group of basal sauropodomorph dinosaur, would have been quite successful biogeographically.
So, broadening out sort of our discussion, I'm thinking a lot about sort of paleontology in South Africa, but also beyond. And you've actually been looking, haven't you, at some of the sort of sedimentology, paleontology, and fossils of Zimbabwe. Is that right?
Yeah, that's right. So we had a paper that came out a few weeks ago, which looks at new sites in the mid Zambezi basin of Zimbabwe. So we looked specifically at the area in Lake Kariba. So we did fieldwork there for a few years. So it's great fieldwork. You get to live on a houseboat and go around Lake Kariba, jumping on islands, looking for fossils. It's really, really, really fantastic fieldwork. And yeah, so the aim of the fieldwork was Volcanodon which is a very early sauropod dinosaur, came from there. But it's nothing else has been recorded from there since it was found like 50 years ago. So we went back to also look at the stratigraphy of the area and then look for new fossils. Um, and so we had a paper that came out at the beginning of the year, which was on the first phytosaur from mainland sub-Saharan Africa, which came from the area. And then the paper that came out a few weeks ago is on all the different sites that we identified there. So it includes uh, phytosaurs and lungfish and amphibians and sauropodomorph dinosaurs and archosauromorphs. Um, and yeah, so it's a very rich assemblage and a very rich area. And then it also looks at the stratigraphy of the area and how that correlates to the Karoo Basin in South Africa.
I think a lot of our listeners will probably, and myself included, will have heard of the Karoo before from South Africa, but maybe they not know so much about it. Could you tell me what is the Karoo?
So when we talk about the Karoo, so we talk about the Karoo supergroup, which is sort of the most widespread stratigraphic unit in Southern Africa. Um, and it ranges a very large geological timescale, and it records. I mean, it yields. Sorry, a very, very, very rich fossil assemblage. So I'm in Cape Town at the moment, and we drove here from Johannesburg. So basically, we drove from the from the northeast of South Africa all the way to the southwest, and by doing that, you cross a lot of layers in the Karoo supergroup, and each of these layers yields all sorts of different fossils. So from dinosaurs to mammal ancestors to just very early tetrapods, and it's just an extremely rich deposit that spans basically the whole of South Africa.
So this new paper that you have out is it focusing on Zimbabwe? So these correlate with the Karoo? Are they part of the Karoo Basin?
So if you look at the paper, so there's a very neat figure that shows you sort of how the different formations of have been identified in Zimbabwe correlate to the main Karoo Basin. So it's the formations in Zimbabwe are part of the Mid Zambezi Basin, and these correlate to the main Karoo Basin in South Africa. So we mainly looked at the pebbly arkos and the forest sandstone formations of the Mid Zambezi Basin, and those correlate to the sort of upper lower Elliott formations and then upper Elliott formations and Clarence formations of South Africa.
And this is quite significant work, isn't it? Because I think when people look at the sort of distribution of fossil discoveries around the world, there are areas where we have much less information about what's taken place in the past. And I think many African countries are not necessarily blank spots because things have been found, but there's a lot less information from those countries than there are perhaps, for example, in Europe or North America. So, what kind of information have you added with this new paper and with the work that's kind of ongoing in Zimbabwe?
Yeah, so I mean, there has been a lot of work that's been done in Southern Africa and Africa, so in Madagascar and Zambezi and Zimbabwe and South Africa and Namibia and so on and so forth. But there's been a lot more focus recently, and even in South Africa as well, on trying to get more dates out of the stratigraphy to try and correlate these different stratigraphic units, not only across Southern Africa but also internationally. And so hopefully we'll get more and more of those in the next few years, which is just, yeah, it's an extremely important thing to do in order to get a better sort of global picture of those paleo environments.
So, I guess before we go, my curiosity is bothering me. I'm just wondering what you said you're going to New York next. I was wondering what you will be studying over the next few years.
So that's a it's
Or
it's
you,
been a
is it
turbulent
secret?
year this year. No, it's not so much secret. It's just been quite difficult to sort of get projects off the ground, I guess. But I'll be working on the more sort of reproductive biology in early sauropodomorph dinosaurs is what I'd like to work on.
Brilliant.
And then also hopefully I've been looking more and more at histology and so the microstructure of bones in growth series of dinosaurs. So I'd like to do more of that, hopefully, in the next few years as well.
Well, perhaps in a couple of years' time, we might get you back on and you could tell us what you've discovered.
That would be awesome. I am definitely keen.
Well, it's been a real pleasure to speak to you. Thank you so much. I know that you're on a kind of whirlwind tour around South Africa right now, so I'm really appreciative of you taking the time out to chat with me and with our listeners about your work.
No, thank you. I'm always very happy to talk about Massespondulus. So anytime, I am here.
Okay, take care and bye for now.
Thanks, Elsa. Look after yourself.
Paleocast was brought to you by Dave Marshall and Liz Martin Silverstone, with contributions from Tom Fletcher, Vish Venkat, and Elsa Panciroli. Music was composed by Patrick Kendall Smith. Paleocast was made possible by funding from the Paleontological Society and the Paleontological Association, but the show now relies on funding from you, the listeners. So, if you've liked this episode, please consider donating, and thanks to everyone that's helped out so far. Please visit paleocast.com for the supplementary material to this episode and for our archive of past programs, and follow us across social media platforms to get all the latest news. Finally, if you enjoy our podcast, then please explore all of our video content on YouTube and follow our other projects, the Virtual Natural History Museum and the Paleocast Gaming Network.